In this video, we're going to look at the prismatic ray, and specifically how you can use multiple prismatic rays together. The prismatic ray is a voltage-controlled oscillator designed from the ground up for video usage. It provides a flexible and stable video source signal that goes from LFO speeds all the way up to the video rate. So let's jump right in and look at the basics. I'm going to take a triangle out, go into one input on my visual cortex. Starting at the top of the module, you have a sync and a range control. I'm going to turn the sync off, go all the way down to the lowest range. Here you see a low frequency oscillator that can be used to modulate any parameter in your system. If I switch up, I get a faster LFO. Switch up once more, and I get into audio rates, which will be scrolling bars, or if I push the sync button, it'll sync and stabilize. Up one higher, we start to get vertical bars, and if we unsync this, we'll get a type of noise pattern that can be useful in your patches sometimes. So I'll keep that synced for now. While it may not look like much, these vertical and horizontal bars can be combined in a variety of ways to create basically all of the shapes and patterns you get from a typical video synthesis system. In this video, we'll look at some of the fundamental ways of combining these basic bars into something much more exciting. You also have a pedestal control, which adjusts the brightness and can be voltage controlled. You have a multiply control, which again can adjust the shape, has independent gain and voltage control, and it can also be switched from 2-quadrant to 4-quadrant mode. At the bottom, you have a variety of voltage control inputs, you have a sync input, and then you have your different waveform outputs. When you're just looking at the black and white signal, the shapes may not look too different from each other. Once we start getting into modulation across different prismatic rays, the shapes will really begin to shine. There's also a square output, which we're going to use for this first example. Perhaps the simplest way to combine two separate prismatic rays is with frequency modulation. I'm going to take the frequency VC input, and take the triangle output from a second prismatic ray. This prismatic ray is set to horizontal bars. And as I increase the voltage control, you can start to see what's happening. And here, as I adjust the multiply, bring this down, you can start to see the triangle shape influencing the second VCO. As we switch to different shapes, you're going to start to see that frequency modulation having something of a different effect. One important thing to note with frequency modulation, the modulating oscillator always has to be at a lower frequency than the oscillator you are modulating. We could also unsync this and go down to LFO rates. Get a different effect. So I'm going to switch this back to triangle. Now, in addition to our vertical and horizontal sync, we can also insert other sources into the sync. I'm going to momentarily take this frequency voltage control out so you can see clearly what's going on. I'm going to take an H plus V ramp from my visual cortex and put this into the sync. And so you can immediately see the result that that's having. This opens up a whole world of interesting and complicated results. If I switch through the different ramp shapes, start to see different effects. And obviously the H minus V will be different as well. Go back to H plus V. Now you may notice the sync input doesn't have any controls. And whenever you see an input like that on an LZX module, your first thought should be passage. So I'm going to put that H plus V ramp into the input of a passage, take the output and go into the sync input. And now that gives me control over how the sync functions. So now I can go back and combine this with my frequency modulation from my second prismatic ray. And you can start to see the controls that we have. Every once in a while it'll get into this kind of staticky zone, so don't worry about it, you'll get it back. There we go, that's pretty nice. And again, if we change the different waveforms, we will get different results. I can also adjust the multiply and the pedestal. And of course I could use an LFO to animate either of these. But in this case, what I'd rather do is animate the signal going into the sink. To do that, I'm going to use a third prismatic ray. So I'm going to take the triangle output from a third prismatic ray, and I'm going to put it into the input on a second channel of passage. Take the output from channel 1 into the through. So now what we're doing is we're taking that ramp and we're summing it with the signal from the prismatic ray and taking that output into the sink input. This prismatic ray is set to audio range, so it's the third notch on the range control, and it is not synced, so it's going to start to give us some scrolling modulation. So as I slow that down, we start to get some nice results. And I can play with how much of it happens over here on the passage. I can adjust all my different frequency ranges and my multiply and pedestal settings. So this starts to open up a whole world of possibilities by using an alternative sync source. And then if you want to make this sync source even more complicated, you can take that basic shape that we have, put it into something like a staircase, and then in turn use that to synchronize that oscillator. So this entire complex pattern is essentially being generated by an H plus V ramp syncing a prismatic ray with a number of modulation sources coming from other prismatic rays. In this case, we're just looking at the square output, so we don't have any gradients, everything's just black and white. We could also switch to triangle, or to any of the different waveforms, and then we start to get gradients. In our next example, we'll look at how to use those gradient outputs in combination with staircase and doorway to create more elaborate shapes and textures. So playing with different sync signals is one great way to get complex patterns. Another way to interact between multiple prismatic rays is with the pedestal and multiply inputs. So to start with, I'm going to take a triangle out from one prismatic ray, and we're just going to take a look at that through color codes. And then I'm going to use a second prismatic ray, again with a triangle wave, on the multiply VC input. So now as I adjust the multiply controls, you can start to see shapes being formed. If you crank up the gain, you start to see more dramatic, contrasted shapes. So now we have some circles. Similarly, you can adjust the pedestal, which is going to give you different types of shapes. Now because the gain is so high on my oscillator, it's actually starting to have something of a keying effect. As we adjust through different waveforms here, we'll start to see the different shapes of the waveforms really shine through. In some cases it's going to be useful to have a slower frequency oscillator. So now, instead of using the high gain on the prismatic ray itself, I'm going to patch in a doorway. Take the key output into layer 1. And to start with, you should see a fairly similar effect, but I now have an independent control over the threshold. Now let's take a third prismatic ray and start to use this to modulate different parameters. So now I'll go into the multiply input on my second prismatic ray. And as you can see, we start to get some scrolling animation. Again, if I bring the gain down, you'll start to see softer shapes. As you bring the gain up, you'll start to get more square shapes because you're starting to clip the signal. Let's keep that down so it's nice and round. Let's take a different output now and use that to add some frequency modulation. Just a little bit, we don't want too much. And now that we have this shape going on, let's multiply this triangle output and also go into the source on a staircase. This is going to allow us to start getting some layered images going on. We'll put that into layer 2 of a color chords. So now because this output is fairly soft, we're getting an interesting result from the staircase and from the doorway, and we can adjust both independently. If we were to turn up the multiplication gain here, we'll start to see that effect from the staircase diminish. So again, let's look at some different shapes, different waveform outputs. To give you an idea, some of the different effects you can achieve. So now, by playing with different frequency ranges, different multiplication controls, you can start to get a wide array of different textures and shapes. And of course, we can use some ramps for effects as well. Start to get a lot of different things going on. Finally on this patch, since I have so many outputs, I can take another one and throw that into the third layer of my color chords. So that should give you some idea of the power of multiple prismatic rays using multiply and pedestal VC inputs. Another great way to work with multiple oscillators is to simply mix them together before hitting further processors, like a keyer, staircase, or any member of the Expedition series. This patch is extremely simple, but capable of great results. So I'm going to take all 3 of my prismatic rays. I'm going to start with triangle waves. And using a passage, I'm just going to patch up a very simple mixer. So I'm going to take 2 inputs into the in and through of one, take that output into the through input of the next one. So that just allows me to mix together all 3 of my oscillators. Then I'll take that output, and I'm going to simultaneously put it into a doorway and a staircase, so you can see the results from both on different layers. Take the key output from doorway into layer 1, and I'll take the divide by 1 output from staircase onto layer 2. So now you can see our pinkish shapes are being generated by the doorway, and our outline green shapes are being generated by the staircase. This way I can demonstrate the results from both processors to the mixed oscillators at the same time. This prismatic ray is scrolling. It's set to unsynced audio rate. That's giving us a little modulation. This one is set to audio rate synced, but I could also go up to video rate. Get some very different results. And this one is my vertical oscillator. So this one, the range is set all the way up to the highest setting, and the sync button is pushed. If you want even more complexity, you can use the sync trick we looked at earlier, syncing to ramps. That'll give you a bunch of different flavors. For now, let's just keep it simple. So as I adjust the mix amounts, you can get a bunch of different patterns. Obviously, you could start to sum any of these with LFOs to animate what I'm doing here. And as you switch through the different waveforms, let's switch these all there. Switch these all to here. Again, playing with the different mix amounts. And finally, let's switch to this. And then obviously we can mix and match. Again, start to adjust the mix controls. Although it may seem simple, just mixing the different waveforms gives you a huge range of different options. This is also a great way to demonstrate the different types of waveforms that are possible in combination. For each of these examples so far, I've just had the pedestal and multiply on all three set to the middle position. I could start to adjust the gain to get more square versions of my waveforms. And of course, I can also adjust the pedestals. Adjust my frequencies, go into different ranges. And of course, from here, you could start to play with adding different signals into the multiply pedestal controls. You can get frequency modulation going on top of this. And start to experiment with a lot of the other tricks we've looked at so far. Even in a small system like this, there are almost infinite ways you can combine 3 different VCOs to get different effects. The examples here are merely a simple starting point for you to explore in your own patching. One thing you may have noticed through all 3 of these patches is that often I'll use one prismatic ray at the highest range, one slightly lower in audio range, and one scrolling unsynced at audio rates. While you can certainly use these in any combination of frequency ranges you want, that's a good one to start with for predictable results. I hope you enjoyed this tutorial, and as always, please leave any questions or ideas for future videos in the comments below. Thanks for watching.